All right, find the equation of the line perpendicular to this line and passing through this point. Now, notice that if you have a single line in space, if you have this line in space, there are many different perpendicular directions. It could be this way, that way, that way. These are all perpendicular to the given line, right? So, without being provided with this point, it's basically impossible to figure out which perpendicular line, what's the direction of the perpendicular line just from this. So that's going to be actually a little more challenging. So let's try to think about the following. All right, solution. All right, so it's helpful if you draw the picture. So here's the line that we're given, and here's the point that we're given. We already know the direction of this line, and we want a line that's perpendicular to. Find the equation of the line perpendicularly crossing. Okay. So we want a line. Actually, you know what? In space, you have, if there are two lines, there are three possibilities. Either they're parallel, or they meet, or if they're neither meeting or parallel, you call this as being in skew. So they can be in skew direction. So even with the original wording, you can still interpret it as that they are meeting, because if they're in skew, you can't really say that they're perpendicular to each other. But just to be clear of what I'm trying to do, I just wrote down perpendicularly crossing. So you have these two lines. So here's the given line, and I'm trying to come up with this line equation, which is perpendicular to the line given. Okay. All right. So we're trying to find a direction that's perpendicular to this one. So we need to find this point which it crosses. If that's done, then we can now come up with the line equation. All right. So the first idea to do it is to first change this into parametric form, because if you change the parametric form, it's easy to talk about the point on the line. So let's change this to parametric form. How do you change the parametric form? Set equal to t and solve for x, y, and z. So if you solve for x, x is equal to 3t, y is equal to 5t, and z is equal to t plus 3. No, 2t plus 3. 2t plus 3. Okay. In other words, for any value of t, this comma this comma this is a point on the line. So what we see is that for any t, okay, 3t comma 5t comma 2t plus 3 is a point on the line. Now, this point is 1, negative 1, 2. How would you find this vector? Or any vector. So this is some arbitrary point on the line. So how do you find this vector? Here's a point. There's another point. How do you find the vector between them? Subtract, right? So if I call this point as point A, and this point as P, then vector AP is terminal minus initial, which is 1 comma negative 1, 2. And that's 3t minus 1 comma 5t plus 1 comma 2t plus 1. Actually, that's a vector. Okay. All right, so that's the vector. Now what do we want again? What do we want between? What do we want these two vectors to satisfy? I want this vector, right? Yeah. So I want these to be what? Perpendicular. What's an easy way to say that they're perpendicular? What do you use? Dot product. Okay. If you have two vectors whose dot product is 0, that means it's perpendicular, right? So that's what we're going to do. We're going to take the direction vector of this. What's the direction vector of this line? 3, 5, 2, right? So you take 3, 5, 2 and do a dot product of 3t minus 1, 5t plus 1, 2t plus 1, set it equal to 0. And then, let's see, that's 9t minus 3 plus 25t plus 5, 4t plus 2 equal to 0. That's 4, that's 13 added. 38t equals to negative 4. This one again. So that means t is equal to negative 2 over 7t. So that tells us, that gives us exact location of this point where it's actually perpendicular. All we have to do is now plug that t value back into here, right? Then that's exactly the point here. Okay? Or we could also do this. For that value of t, this vector is now perpendicular direction, which is exactly what we want, right? So we can plug this back into here, and that will give me the direction of the line that we want. And after that, since I have x naught, y naught, z naught, and that there we have the answer. Okay, so let's do that. Let's plug it in here. 17, 2 over 17, so negative 6. See, negative 6 minus 17, that's negative 23. So if I plug this back in here, AP vector is now negative 23 over 17. And then if I plug it in here, negative 10, 7 over 17. Plug it in here, negative 4. Negative 4, 17 minus 4, 13 over 17. Okay. That's the direction of the line. And by the way, you can use any multiple of this and it will still describe the direction of the line. So you're free to use this one, but if you like integers rather than fractions, since that all of them has 17 there, you can multiply by 17 and use that as the direction of the line. Okay? So let's do that. I'll multiply by 17, and here's the answer. We know that the direction is this, comma, this, comma, this. Written in symmetric form, it'll be negative 23, 7, 13, downstairs, and then x minus the given point, x minus 1, y plus 1, z minus 2. So x minus 1, y plus 1, z minus 2. So that's the answer written in symmetric form. If you set equal to t and solve for x, y, and z, and that will give you the equation in parametric form. If the question doesn't specify which, either one will be correct. Okay?